Welcome to our overview of first grade space systems. In this unit, students will be making observations, either firsthand or from media, to collect data that can be used to describe patterns and make comparisons. Patterns of the motion of the sun, moon, and stars in the sky can be observed, described, and predicted. At night, we can see the light coming from many stars with the naked eye, but telescopes make it possible to see many more and to observe them, the moon, and planets in greater detail. Seasonal patterns of sunrise and sunset can also be observed, described, and predicted. In the first set of lessons, 1 through 8, students will learn how to use the patterns of objects in the sky to provide evidence that future appearances of those objects can be predicted. For instance, if the moon is observed to rise in one part of the sky, a prediction can be made that the moon will move across the sky and appear to set in a different portion of the sky. Or, if the sun is observed to rise in one part of the sky, a prediction can be made approximately where the sun will be at different times of the day. In order to generalize their evidence, students need to first collect and organize their observations, or data, of objects visible in the sky during the day and night. In lessons 1 and 2, students are using pictures, text, and video to observe how the sun appears to move across the sky. The optional video in lesson 2 models how day and night are caused by the Earth's rotation and introduces the predictable patterns of seasonal change through the Earth's revolution or orbit around the sun. While seasonal change is an observable pattern, students do not need to understand or know about the process of seasonal change. Lesson 2 includes an exploration activity where students are using a tennis ball and a ping pong ball to demonstrate the pattern of what causes day and night to occur. This activity could also include students modeling the pattern in pairs where one student acts as the sun and the other acts as the earth. Lessons 3 and 4 introduce a log for students to document their observations of the moon over the course of 1 month. When introducing this activity, consider starting the log with a full or new moon to help students see the pattern. Included with this set of lessons is the activity, What Does Each Moon Phase Look Like? To help students use their data from their observational moon log, it might be beneficial to have students complete the activity after the log is complete. Students can then use the data to sequence the various phases of the moon based on their observations. In Lesson 5, students continue to examine observable patterns in the night sky as they view how the appearance of the moon changes over the 29-day cycle. Both of the videos included within the lesson provide time-lapse of these changes. Based on the performance expectations, students do not need to know the specific terms used to describe each phase. The emphasis is on having students collect observational data to describe the patterns. Students have likely observed other things in the night sky besides the moon, such as stars. In What Does the Sky Look Like? Lessons 6 and 7, students are using their experiences and observations to create a model of what the night sky looks like. Using the infer questions, discuss with students why stars are not visible when it's cloudy and include why stars are not visible during the day. The video included with Lesson 8 provides visual evidence for the observations that students have collected through the first 7 lessons of this unit. This is an opportunity to discuss with students the importance of documenting their observations and how their observations can be used to predict future patterns or create a model to show what might happen in the future. In the final sequence of lessons, 9 through 12, students are asked to collectively make and record observations about the relative length of day in different seasons to make comparison between the amount of daylight at different times of the year. In Patterns of Daylight, the teacher will guide students through a computer simulation of the amount of daylight that is visible during different seasons. Prior to this activity, take time to review the features of the Moon Giant website. For Lesson 11, students are continuing to use their observations to compare the amount of daylight at different times of the year. But instead of using pictures or a computer simulation, students are examining graphical data, and will use this data in Lesson 12 to make conclusions about patterns of daylight at different times of year. The materials for this unit have been included within your material kit and are outlined here on this slide. As you are planning these activities, please feel free to contact us with any questions, to request support, or share any ideas.